ratios whereby we have cos and then we have sine. The first thing that we can attempt to do here is to try to check if we can change it to 10. That's the first thing that you should always check. Check if you can change it to 10. Now, how do you change it to 10? And then when do you change 10? When do you change 10 to the other angle? So we are saying if you are given the 10 identity, which says that we have sine theta all over the cos theta. What is very important here is that the angle, these two angles should be equal. So we should have 2 theta here, and then we should also have 2 theta. If we have 2 theta and 2 theta, then we can change it to the tan identity. And then, was it you moving? Yeah. Now, tan, when we are dealing with a general solution, we usually don't change 10. We solve it as 10. It's not necessary for us to change it into this identity. We change it usually when we're busy solving our identities, the left-hand side and the right-hand side. So when we're busy with general solution, like most of the time, we don't have to change it. We just have to solve it as 10. So in this case, what we're going to do, we're going to reduce this. We're going to write it as a reducing angle. So if we write this as a reducing angle, they're saying this can be written as cos 90 degrees minus 2 theta. And then they say this is going to be cos theta plus 30. Now from here, we can clearly see that we have cos, which is equal to cos. Then we can say that we have theta, which is plus 30. It's theta plus 30. So we're going to write this whole thing exactly the way it is. And we're also going to write this one. So we say we have theta plus 30, which is going to be equaling to 90 degrees minus 2 theta. Now, whatever is written here is going to give us the direction where we are going to work. In fact, we should have started there. So we start here and then we say we have our cast diagram. It's wrong. Yeah. So I should have what T here. Yeah, I should have C. So we have our cast diagram. Okay, fine. So where is cos going to be positive? So we take the first quadrant and then we also take what then? The fourth quadrant. Now, what do we have on the first quadrant? First quadrant, we can accept this reference angle. Here, we are going to have 360 degrees minus our ref angle. So we can then put this thing according to the first quadrant. I saw other learners were only writing only for the first quadrant. So you need to have both quadrants. Where is positive? If it's positive, it has 2 quadrants. If it's negative, it also has 2 quadrants. So we have 30, it's theta plus 30, which is going to be equaling to 90 degrees minus 2 theta. It's not 20, this one. Plus K multiplied by 360 degrees. And then we can say K is an element of all the integers. It's fine, okay? Now, then we go and simplify. If we simplify the following, we are going to have, we are supposed to take this 2 theta, which is positive, okay? You take it to this side. It's going to become what? It's negative, okay? When it goes to that side, it becomes what? Positive. So we have 3 theta, and then we take 30. If we take 30 to the side, it's going to become what? Negative. Negative. So you're going to have 90 minus 30. What is 90 minus 30? So you have 60 degrees plus K multiplied by 360. Okay, from here we want theta. So we divide through by 3, divide by 3, divide by 3. And then it says, therefore, our theta is going to be equaling to 20 degrees plus K multiplied by 120 degrees. So this is going to be our general solution for the first quadrant. Next, we need to talk about the fourth quadrant, IV. So on the fourth quadrant, we're going to have 0 plus 30, which is going to be equal to 360 degrees minus, put it inside the bracket, since we have 2 terms. So what do you have as your 2 terms? You have 90 degrees minus 2 theta. This is your reference angle, and then you say plus K multiplied by 360. K multiplied by 360. Okay. So from here we can say we have theta, which is going to be equaling to we have 30. We take it to the side. Okay? If we take the 30 to that other side, it says you have 360 degrees minus 30. Okay? Now you have negative and positive. What do you get? So you have minus 90. And then you have a negative and a negative. It gives us plus 2 theta. And then it says plus K multiplied by 360. Okay, here we have like terms. We can then take this 2 theta to this side. If we take 2 theta to that side, it says that we are going to have theta minus 2 theta, which is going to be, it's 360 minus 30. It's 330 minus 90, 240. So we have 240 degrees plus K multiplied by 360 degrees. And then K should be an element of all the integers. But we're not done yet. Okay, so here and here. If we say theta minus 2 theta, what do you get? So we have negative theta, which is going to be equal to 240 plus K multiplied by what? By 360. Then we can divide by negative 1, divide by negative 1, divide by negative 1. It says theta is going to be equal to minus 240 minus K multiplied by what? By 360. And then this is going to be our general solution for the fourth quadrant. So you say